Thank you, Bernard and Michael, for inviting me to give this talk on deploying Ruby on Rails applications on production servers. So I do a lot of DevOps stuff, and also software engineering, like on the back end, and I write a lot of software running on the web. So recently, I'm usually in the Python ship, but I think like 3 weeks ago, I just was tasked to do something. It's like a distraction. So I was just playing around with Ruby on Rails, and this guy asked me, hey, can you do this for me? And so I actually migrated a whole Ruby on Rails application, web application that was on production for about 3 years and had paying customers, had a big database, and I moved it from one cloud provider to another, and I learned a lot of things, so in the Ruby space, that is, but what I noticed was that things were the same across board, whether you're doing a Ruby on Rails application, are you doing a Python Django application, are you doing a maybe in Java use Spring. Everything is a bit similar. So I'll just try and talk of overview. I didn't want to get very hands-on and code some stuff here, but I'll give you like the bigger picture of what you should be thinking about. So this talk will just tell you about what you should think about when you're putting your app on production. So most of our applications, when you're learning Ruby on Rails, you start with your app and you set up Ruby, first install Ruby on your local environment, and then you now set up Rails. But that app will never live like in your machine, but will eventually be put out there for people to use. So on a production instance, can be a platform as a service, can be an infrastructure as a service, can be on a Roku, can be on an App Engine, can be on, on AWS, EC2, Compute Engine, can be on so many providers. Then your code needs to be versioned, and Kevin talked a lot about that. And also there's something called Git flow. You need to have good processes. You won't maybe be the only coder in the team when you're building this, and maybe you're a team of 5, you scale up to 10, to 50, to 100. And they're different. So when you have a lot of people in the team, you're 5 people. Okay, when you're 1, you know all the keys. You can just have the same keys or configurations. But when the team grows to 5, 10, 50, 100, then you start having configuration issues, because this is on production, this is on staging, this is my dev environment. Every developer wants to have their own, kind of environment and tools that they use to be productive, and this becomes an issue. But again, you've built your app, it's on production. Now you face this challenge. You have paying clients, and they see a 404 error or a 500 error, which is very bad for you. You're not supposed to have downtime. You're not supposed to have these errors coming up. And how do you fix it? How do you monitor this? How do you make sure that the app resources are okay? Let's say you went to a server, you bought the least compute power. Let's say, for example, DigitalOcean was $5 an hour a month, and the traffic has gone up, has beat the compute that box has, and the server is going down. So how do you prepare for that? And also there are a couple of things, we do a lot of releases. Your app doesn't just stay static, you'll always be updating it. So how do you manage releases and don't do those ad hoc tasks? Remember, if you do some changes to your database, if you change something on your code, so remember what you'll do on your machine. You'll go do a Git pull, have the current, on remote. For instance, if another developer was developed, then you'll run migrations. Then after you run migrations, you'll do some other task, restart If your stack is passenger and Nginx, you'll restart Nginx and passenger so that your app restarts and sees the new. You'll also need to precompile assets. So there are these kinds of tasks that you keep doing, and it needs to be done on production, on development, on staging, and so many environments. So how do you make sure that you have this? So this is what my talk will be about, and will be more of an overview and discussion. Some things you should like think about, and because I find that us developers do not sometimes just think about. You just think about shipping fast, and then when you get an investor, or these are some of the questions. If you're building an application and then you're thinking at some point to raise money, like these are some of the due diligence that the investors will look at. And if you don't have these kinds of stuff and you're not thinking about them in this way, then things will get very bad. So DevOps. So what is DevOps? So this, I actually got this slide from my friend James Moy, who did like a very good analysis of what DevOps is and what's allowed. So this has been a term that's been, if you look at it, there's dev and there's ops. So it's developer and operations combined. So, the first part, developer, focuses on software development, which is code, testing, and deploying. Then the other one, the ops part, is in QA, that's in testing and continuous integration. Kevin mentioned a lot about that. Then there's ops, there's orchestration, like what is going to that server, and there's logging and monitoring. You have to think about this. So when you're doing a web, you're building software on the web, you have to think about these three things. So there's development, there's the engineering. This is the code, the logic of your app. Then you need to do quality assurance. This is making sure that everything is fine, integrity and everything. And then there's operations, like are you checking your monitoring and logging? Are you, what's happening on the server? All those stuff. So this is DevOps in a nutshell, and DevOps is what comes in between those three circles. I mentioned another major thing is version control. So I like how Ruby on Rails just forces you to use Git. He talked about how in PHP you could just do it on FTP and just upload your server by FTP. But if you do the Rails tutorial from the onset, it's the first thing it tells you. Install Git, tells you to go to, I think, GitHub, and in version control, it's not only Git that was there. So Git is the most popular as we speak right now, but it has gone through an evolution, and I'll just pick up on a couple of them that are also popular, like Mercurial came after Subversion, and it's from the Subversion guys, but it's also like hosted on Bitbucket. And then we have Subversion that was very popular, especially between the 2000s and 2010, like Subversion, and you'll still find a couple of people using Subversion. CVS was also there. So version control is a concept that has been there time in memory. It's not a new thing. So people think version control, they just think Git was the only one. So Git is just, it's a technology, or it's a version control, how do I put it, like a protocol or a standard. Yeah, that's a good way of thinking about it. So it's a kind of standard, and is offered on a lot of platforms. So most people just think that GitHub is Git. So GitHub is just a platform that is running on top of Git. GitLab, that my friend Kevin works for, is also a competitor of GitHub. And also Bitbucket from Atlassian also has Git. So there are so many options, and all these platforms have their perks. And most people, it's just that most people use GitHub for public repositories, and so many people are on GitHub. So there it doesn't matter. It's just that it's the most popular. Doesn't mean maybe it's the best, or there are so many options. So I'd like you to know that you can also put your code on Bitbucket, on GitLab, on GitHub, or source repo. There's so many of them. But now the interesting thing is Git flow. So you know Git, you know how to push, you know how to, okay. So there are basic things with Git. So you make a change, you add it you stage it, and then you commit it, and then you push it. And you push it to one branch, which is master. By default, that's the only one. But what happens when you're 1, 2, 3, 4, you're 5 developers in a team? You can't be pushing every time to master. How many people have ever had things like merge conflicts, and you're like, shit, like, where did this come, and there's rebasing, and it gets messy. And that's where we have something like Git flow. So what Git flow is, and he talked a lot about CI and continuous delivery, continuous integration, and Git flow is a concept by, I can't remember, Daniel Kramer. Yeah, Daniel Kramer came up with this concept called Git flow, and it's very, very good if you're in a company, a small team of 5 or 10 people. And what basically it does, you have one branch called master, this is your production branch. Then you have another branch called develop. Develop, from even the word develop, developer, that's where developers, meet. No one commits directly to master. And then you have something called feature branch. So if you're working on a feature, if you're coming out from, if it's a new developer, developer 1, developer 2, they'll just every time branch out from this feature branch. So you have feature, and you can see like feature, and then this other guy from develop came around, started a new feature, and continues, and then push. If you're done with your feature, you merge it back to develop. So all developers meet at the develop branch. Then now you have things like hotfixes. There might be something that came out, broke something by accident. Maybe it was a traffic, it's a tweak. So you come up with a hotfix branch that comes directly from master, does the hotfix and pushes it back. And remember, you have to put a tag on it. Then there are a couple of things after you do a couple of features. So when you're thinking agile, there are a couple of things that people look at. You can maybe have a scope and say, after this week, if you can have like a roadmap or a pipeline and say, if we do 10x or x features, let's say you do 5 features, that's a release. If you do 5 bugs and issues, if you fix them, that's a release. So in the features, so these are features. You can also have issue branches. You can have fix branches. You can have a couple of branches. And it doesn't matter. You don't have to call them feature. So you can call them any name. But this is just the roadmap. It should help you understand how Git flow works. So when I say that developers do not merge to master, it's either one person dedicated in the team who does the peer-to-peer reviews or code reviews and then merges it to master, or it's very automated with a CI or a CD. So in this, think about Jenkins or Go or something else merging from this release down there or creating a build. So I won't go into too much detail, but I'll just tell you to just go and look at Git flow and see how you can actually use it in your projects. So another big monster that comes out when you're deploying your app, a Ruby on Rails app, is configuration management. There's a very good quote from the Ruby community that says convention over configuration. And that's something I love about Ruby on Rails. I wish we had it on in Python, in Django as well. You have some specific configuration, like if you're using Nginx and Passenger, and you're deploying on a server, you have the IP name, you have, there are a couple of configurations. There's an Nginx template that you're using for your app that's custom. And also DB configs. You can have a local DB, let's say you're using Postgres, that's very popular in the Rails community as well, or MariaDB or MySQL. You'll have a database and its credentials, you have your locals, you have one in production that's different. So these are some configurations that usually needs to be managed. So there are a couple of tools of trade. There's Ansible. I like using Ansible. I find it very easy, and I think it's something that I got really comfortable with. But I have used Capistrano, I've used Puppet, I've used Ansible, I haven't used Chef or SaltStack. But the most popular with most Ruby on Rails developers is Capistrano. It does a lot of task automation and a bit of configuration management and deployment. Ansible is very popular, especially with the Python community, because it's on Python. It's built on Python, but they built Ansible using Python, but it doesn't mean that it's you write Python code inside it. So it's just YAML configurations and playbooks. There's Puppet and Chef. I actually used Puppet a while back when I joined the DevOps world. Puppet, Chef, and are written in Ruby, and I think they're very popular as well. Capistrano can also be used in other languages. It's not. Doesn't mean that if Capistrano is written in Ruby, it can be used by the Python developer. It can be used by any developer. We have recipes, and there's a lot of documentation around it. Ansible as well, written in Python, though recently acquired by Red Hat. As I said, it uses like the YAML syntax, so you don't have to write like .py folders inside. So we have in Ansible we have playbooks. In Capistrano we have recipes. In Chef, I don't know, I can't remember. They also have like a name for their playbooks or recipes. So this is an example of Ansible playbook, and these are kind of like the tasks. For instance, if you're telling it install Nginx, does it need sudo? Package Nginx tells you, this is the template. So it uses something called Ginger templates, and you can actually like define how your Nginx folder will look like. And then say install the Nginx configurations, get them from this, put those variables, put them here. You can actually hash your variables with something called Ansible Vault and hash them so that they are secure, even if you're versioning them. And then the other thing is now monitoring and logging. There are a couple of tools that you can use to monitor and log your file. Recently, Google acquired Stackdriver, which is a startup that's built like a very, very comprehensive monitoring and logging solution. Google as well has their own, on the Google Cloud platform, they have something called is cloud logging and cloud monitoring out of the box, but they have Stackdriver, which I'll find like a very, very good tool to use. There's New Relic, which is very popular, CloudWatch, Nagios. So this integrates with your infrastructure as a service very well, and you can actually monitor how your app is doing, like performance. How is it computing resources? Like most Ruby on Rails developers, especially if you're doing the tutorials, they don't they prefer to just use Heroku or something like App Engine or just any platform as a service. But you only benefit from Heroku if you're just prototyping very fast and using it. But when your app architecture becomes serious and you're using workers and Dynamo and like for instance, you're processing a lot of things that are RAM intensive and you have like workers, if you're using like Redis and all that stuff, now you start feeling the cost. If you get to a certain threshold, you have to pay, and you have to like really work towards making sure that your application goes with Heroku's architecture. So you can write to their file system, you can do sorry, all these things. So you get to experience not fully like a very robust architecture. So that's why sometimes you are forced to now move to an infrastructure as a service. You can start on DigitalOcean or Computer Engine or EC2 and put your app there and get rolling. And now when you move from a PaaS to an infrastructure as a service, now you have to figure out everything, cloud, monitoring, and all these issues, you have to figure them out. But when you're on Heroku, they have a dashboard, you can see your analytics and everything, so you just focus on the developing. So there's also logging. There are a couple of very popular logging tools, Sentry, Logstash, Kibana, Datadog. There's so many logging issues. I used one called Papertrail on Ruby, and all my logs for the app will go to Papertrail. So I'll just log in and go to the Papertrail and see the logs. Papertrail was so good, such that I could see even to the bits of a user signed in, a user did this, a user did that, and all. And if I had a stack trace, I'll be able to go back to the logs and be able to see what had happened. So I used Papertrail for my Ruby on Rails application that I had deployed a couple of weeks ago. When you're now talking about deploying your app on production, there are a couple of things you should think about. So I just created a small guideline. So most of the time I'm running teams and making those decisions. Which technology stack are we gonna use? So I'll try and help you as a developer to try and figure out some of the things that you need to think about every time you're starting a Ruby on Rails project. What are the guidelines? So I'll take a use case. If I, right now, was developing a Ruby on Rails application, what will I think about? So first, I'll think about versioning it with Git, because Git is really powerful, and I really feel comfortable with it. But depending on your team, if you feel like you can use Mercurial or Subversion, I'm not locking you down. You can use whichever version control system that you want to. Then I'll apply, a way, because I might know that my team at one point might grow from me alone or 2 people to about 5 or 10. So I'll apply Git flow into my architecture and Git flow guidelines within the team. So we have like a roadmap. You could hear Kevin talk about the rules at GitLab and how they deploy. There are a couple of rules. You cannot merge your branch to develop. Somebody has to go and review it and merge it. So there are a couple of those things and guidelines that needs to be set out. Then I'll choose one configuration management or orchestration tool. So depending on the level of my project, if my project is very minimal and I'm writing maybe Python or a Ruby script, I'll prefer maybe to write it in a Capistrano recipe, just a small, because it's just doing small things. But if now, depending on the time, so it doesn't mean that every time I will start very heavy and spend more time doing configuration management. Because you can't just focus on that, you need to also balance your time on the developing on your app. So you'll come up with a quick solution that minimizes time depending on the stage of your app. So you could start lean with something like Capistrano, and then if the architecture moves and start becoming complex, then you can rewrite that and rewrite it with Ansible. So there's something called tech debt. So every time you're building something, you have to balance between time, resource, cost, and all these things. So you have to think about all these things when you're shipping. That's why, if you're, Ruby on Rails speeds up a lot of things with via scaffolding tools. So you also have to think about how I'm going to release my app very fast to my users and get feedback. And how do I do it to the least cost and the least amount of effort? And I don't want to do ad hoc repetitive tasks. And building, you also look at how much time will it take me to build an Ansible playbook? How much time will it take me to build this Capistrano recipe and ship it? So you have to weigh on this. and see which one is better than the other, and then see which decision you'll make at which stage. So another thing I'll do is now I'll think about daily, weekly, or monthly builds. So Kevin talked about builds, with Go, with Docker. I'll look at how am I building. Will I put a CI to check my unit tests? Will I put, how am I releasing my app most of the time? Am I going to do it weekly? Am I going to do it daily? If you have a big team of 50 people and they're working full-time, 40 hours a week, then a lot of stuff will be done by 1 week. So probably you might have daily builds. So someone at a point in the timeline is finishing a feature and needs to go up. So maybe you might have daily builds. But again, as I say, with the use case, depending. So you can't be one developer and you're giving your project 10 or 5 hours a week and then you keep saying that, hey, I'm going to give it daily builds. Because what are you building? What's in that build that you're putting up? Do you have a feature that's already up? So, but if it's in a company or in a team of 10 people and people are committing 40 hours a week and they are shipping a lot of code, then that is relevant. Then I'll also put something, a monitoring and logging tool like Papertrail. So I'll be able to monitor my app and see what's happening with my users, follow up, see if there's a spike, see which IPs, where are my users coming from. You'll be able to understand your user. Then I'll also put issue tracking and a process of solving bugs. How do I catch issues? Once a user complains about a thing, do I have a ticketing system? Do I have a ticketing guideline? Put it up, put it in your flow of how you're developing and actually solve it, make time and, have an issue, have a way of solving your issues in that work week that you're working on your project. Then again, think agile. I'm not going to talk about agile, but it's very good to start thinking agile. If you don't know much about agile, just Google about the Agile Manifesto. And I had Kevin again talk about Martin Floor and talk about the quotes and everything. And if you start thinking agile, then all these things, my session and Kevin's session talked about, start making sense. So this, my friend James Moy is my colleague at I Am Consulting, and he usually likes asking developers these questions. Can you make a build in just one step, one command? Or do you make daily builds for your app or your projects or wherever you're working? Do you use configuration management tools to automate your infrastructure and orchestration? And then, is the development documented and automated? Like, is it if a new person just comes to your team, how fast do they get up and running and start shipping code? And then, can you roll out and roll back deployments in one step? Let's say there's one thing that was checked into master and broke stuff, and there was a previous good state. Can you do that in one command? Another one is, can you actually move, if something happened to your compute instance, could you stop it and roll up a new instance? Let's say your site was hacked. Can you just kill that instance and spawn up a new instance somewhere else and not have downtime for your users? So ask yourself all those questions, and that's how now a modern web developer is thinking. So if you're not thinking about this, you're still not modern yet. So make sure you're thinking about these things all the time when you're developing. There are a couple of things that I also didn't talk about, a lot of detail, but these are some of the overviews that I felt if you're developing any app, any Ruby on Rails application, and you want to put it up there on production for your users, that you should be thinking about every time. Yeah, my name is Kenneth Kinyanjui. Feel free to always tweet me. My email is there, ken@fideka.co.ke. And if you have any questions on the Google Cloud platform, feel free to ask me. um, yeah, and yeah, I think that's it. Thank you very much. I think I didn't do that bad on time, did I?
No, you're excellent on time. So
Okay, maybe I can take just one or two questions.
Yeah, two questions.
Yes.
First one. Who wanna go first? Okay. The second one. Who wanna go second? Oh, okay.
Cool. You know, when people don't ask questions, you're like, did I talk so much complex stuff or was it just easy? Okay, just ask me, Cornelius.
Okay, so my name is Cornelius, and I'm asking about these tools for DevOps.
Yeah.
I know you've mentioned so many, but I'm coming from a mobile background, and somehow I feel that I need to do a bit of web so that whatever I'm building complements each other very well. So what kind of tools can you maybe point me towards, considering that you mentioned so many tools on configuration, monitoring, and logging, and also in deployment? Yeah.
Okay, so there's this chart, right? I'll just take you back to this chart. So this is DevOps. So there's three fundamental things. There's your there's your software engineering, there's your QA, and there's your tech ops, right? So if you're doing, are you doing Android? Yeah. Android, right? Are you doing it native or hybrid? Native, right? So I can imagine you have, you're building it in Java and you're doing builds and actually automating the process and releasing to the Play Store, right? Okay, and do you have, what's the nature of your app? Does it have APIs or do you have a web service on the cloud, or how is it working? Okay. So you're using Firebase, right? Okay. And what else? Do you have a database on the cloud, or Firebase is taking care of that? Okay. So, so meaning that all your engineering time mostly is spent on, your engineering time is now spent a lot on building the Android app, right? Okay. So now there's actually someone who wrote a very good post on how to come up with a Git flow and process for shipping your app on a good process of building your app, your Android app, and then shipping, following the right protocols. For instance, Git flow, versioning, releasing, and all that stuff. But you have to balance. I know I mentioned about a lot of tools, but it all goes back to this. Don't get lost in the tools. Get lost here, because this is the place that you should like look at. This like your chart. So you're thinking about, am I spending my time on engineering? So from your architecture, then I can say that. And if you're building an Android application, that means that Google and Android Studio is making you do, and Java by de facto is making you do builds every time you're deploying stuff. When you release something on Android, the Play Store, you have to write the version. You have to do it. So you're actually being forced to do it. I know some people are like, why can't I just push it? But they actually make you do it. So I'm trying to get your question, because the solutions that you mentioned are like fixing it. So you don't need to, I don't see you needing to automate. Yeah. Yeah.
Okay, it has both mobile and
Yeah.
web. So there's the mobile part, and then there's the web.
Ah, okay. So I think you should have told me about my web app.
And
So
then
tell
the
me
web
about.
part is now in Ruby now.
Oh, okay. So you have a web application, right? Okay. In Ruby. So you want me to give you an ideal way you will use. Okay, I'll just ask you just some few questions. How complex is your Ruby app? What is it doing? A lot of things. Is it very robust? Are users signing up from the Ruby app? Are they doing a lot of operations inside? They are not doing. So it's just a service. It's an API. I can imagine. So how frequently do you update it? No, I just asked how frequently do you get to update it?
Like I'm still
Could you give
building.
me a number like in a month?
Let's say twice.
Twice.
Say twice, yeah.
Okay. So if you only go to your app twice, and okay, what are the things that you update most of the time? Is it just code, logic, or do you do like some major features?
Mostly code reviews.
Just code reviews
Yeah.
and then merge. Okay. So if it's not a very big architecture, as you're saying, because your architecture seems to be spread out from an Android, there's a team that's working on an Android, the Android side. You have Firebase that's handling those database and real-time sync, and you have just Ruby that's in the middle as your service, right? And your API and everything. So that means that most of the time, a bit of times you'll be changing the API and the service. Okay. So that one, I'll just recommend just use Capistrano and write some task automation tools in the recipe. And where are you deploying it? Are you deploying it on Heroku, or is it, I imagine, Heroku? Well and good, then if you're doing it on Heroku, then you don't even need Capistrano to do it, because you just say Heroku push or something, because it's a platform as a service, as like covered everything. But if your architecture then moves from Heroku to an infrastructure as a service, then at that point you'll need to have all the things that I mentioned. So if you're using a platform as a service like Heroku, then the technology operations goes, no ops. For if you're using a PaaS, there's no ops. So orchestration, logging, and monitoring is already covered by that person who's giving you that. And now you just have to hook up a CI, continuous integration, and a testing. So you only think about QA and software development. So just write unit tests, hook it up to either CodeShip or something else, and every time you merge into develop or master, it runs those builds and actually deploys. So there are so many automations from Heroku that you can use. So I don't see yourself needing to move to an infrastructure as a service if your architecture is not that heavy. So have I answered your question? Okay.
Yes, and here is the first question.
Hi. You talk about infrastructure as a service. What do you mean? What do you mean by infrastructure as a service?
Infrastructure. Okay. So infrastructure. Oh, let me move to this side. Okay. Infrastructure as a service is when you buy compute. How do I put it?
Hardware?
When you buy a Linux box, for instance. So infrastructure as a service is, for instance, buying this computer, only that now because the computer, we don't have like good internet and all, so we have to buy some space from a server. It can be from AWS, can be from Rackspace, can be from Linode, can be from Google, Microsoft with Azure. So infrastructure as a service is when you go and buy just a small box somewhere. But now platform as a service is when you're buying that, now these companies have come up with a product that has figured out most of these issues, and they just want you to focus on the software engineering part of that, and you pay as a service. So You have sometimes they have free tires until you get to some compute. So a good example is Heroku for Pass, Google App Engine. This which other one? This Python Anywhere. Like I don't know much about. Heroku has dominated the Pass Elastic Beanstalk with Amazon. But now if you're talking about infrastructure as a service, a good example can be a DigitalOcean box that you're getting, a Linode box, Google Compute Engine, Amazon EC2, which is Elastic Compute, Azure, they have their own compute. So in actual sense, in IaaS, you're buying specific things. So you're buying compute and a server, and you actually even detect which operating system is going to be there. Is it going to be an Ubuntu box? Is it going to be CentOS? Is it going to be Red Hat? Can it be Fedora? All those factors. So I think that's detailed. Have you understood? Okay.